morning everyone. We are dealing with the chapter motion and laws of motion. Okay. As you know that in the last class we have studied about Newton's first law of motion and momentum. In Newton's first law of motion, it defines about force and inertia. Okay, Newton's first law of motion describes about force and inertia. Okay, so from today's class we are going to study about Newton's second law of motion. Okay, second law of motion. Newton's second law of motion. Okay. I think it's a familiar word up to you, isn't it? So, the Newton's second law of motion helps to measure the force. Okay, Newton's second law of motion helps to measure the force. Once again, second law of motion helps to measure the force. Okay. Consider the velocity of a moving body changes from u to v. Okay. Once again, consider the velocity of a moving body changes from u to v. When a force F is applied on it in t second. Okay. Once again, I will say consider a velocity of a moving body changes from initial position to final position. Okay, when a force is applied on it in t second. Okay, so we can write the rate of change of momentum of the body is how can we write the rate of change of momentum of a body? The rate of change of momentum of body is m into v minus u by t. Okay. We can write the rate of change of momentum of a body like this, m into v minus u by t. Okay, I think it's a familiar equation up to you, isn't it? So, A is equal to v minus u by t. You have studied earlier. Okay, so A is equal to v minus u by t. Okay, so we can say that the rate of change of momentum of a body is directly proportional to the applied force. That is the Newton's second law of motion. Once again, I will say the rate of change of momentum of a body is directly proportional to the applied force. Okay, how can we write that? We can write F directly proportional to m into v minus u by t. Okay. F directly proportional to m into v minus u by t. Then how can we state the second law? The second law states that the rate of change of momentum of a body is directly proportional to the unbalanced external force acting on it. Okay, once again I will say the rate of change of momentum of a body is directly proportional to the unbalanced external force acting on it. Okay, so here v minus u by t is a. So for finding acceleration we have an equation that is a is equal to v minus u by t. Okay, acceleration is equal to v minus u by t. Okay, so we can write F directly proportional to ma. Okay, so I am taking v minus u by t as a. Okay, once again I am taking v minus u by t as a. So we can write F directly proportional to ma. Is it clear? So using this constant, the above equation can be written as using with the help of a constant. The above equation, this equation we can write like this: F is equal to KMA. Okay, look at here. So we can write F equal to 1 Newton and M equal to 1 kilogram. Then A is equal to 1 meter per second square. Okay, the unit of force is Newton and the unit of mass is kilogram and the unit of acceleration is meter per second square. Isn't it? So we can apply these values here. Here F equal to 1. Here I am writing as K. Then we want to find the value of K. So I just write here K. Okay. Then M is equal to 1 kilogram. Then A is equal to also 1 meter per second square. Okay. So therefore we can write K equal to 1. Is it clear? So we can easily get F equal to MA. Is it clear? So this is the equation for measuring the force. Is it clear? Once again I will say the Newton's second law of motion states that the rate of change of momentum is directly proportional to the unbalanced external force acting on it. So we have an equation for measuring the force. The equation is F equal to MA. Okay, we can do some problems based on these equations. In page number 52, you can see some questions. Okay, we want to do that. I will read the first question. A car moving with a speed of 108 km per hour comes to rest after 4 seconds. Okay, on applying a brake. Once again, a car moving with a speed of 108 km comes to rest. Here the initial velocity is how much? Here the initial velocity is 108 km per hour. Okay, then the car comes to rest. That is the final velocity. So we can write final velocity is equal to 0. Is it clear? Then comes to rest after 4 seconds. Here the time is also given. Here the time is 4 seconds. Okay, is it clear? Then if the mass of a car including the passengers is 1000 kilogram, here the mass is also given. Here the mass is how much? 1000 kilogram. Okay, M is equal to 1000 kilogram. Okay, then what will be the force applied when brake is applied? We want to find the force here. Okay, so here the initial velocity is 108 km per hour. Then here the final velocity, when the car comes to rest, it is 0. Okay, so here the final velocity is 0. Then here time is given as 4 seconds and here mass is given as 1000 kilogram per meter, 1000 kilogram. Okay, so we want to change this initial velocity in kilometer per hour. Okay, how can we change that? By multiplying with 5 by 18. Okay, so 108 kilometer per hour. So how can we change that? By multiplying 5 by 18. Okay, by calculating this we will get as 30 meter per second. Okay, by calculating this we will get as 30 meter per second. So here the unit of initial velocity is meter per second. Okay, so I write as 30 meter per second. Okay, then so according to Newton's second law, we have an equation that is F equal to MA. According to Newton's second law, we have an equation that is F equal to MA. Okay, so we can write this as M into V minus U by T. Okay, here acceleration is equal to V minus U by T. So I write here. Okay, then we want to apply these values into this. Here mass is 1000 kilogram. Here mass is 1000 kilogram. Here V is 0 and U is how much? That is 30 meter per second. Okay, then here T is 4 seconds. Okay, is it clear? So by calculating this, we will get as minus 7500 Newton. Minus 7500 Newton. Is it clear? Is it clear? So here the force applied when brake is applied is, we want to find here the force when brake is applied. Okay, so here that is minus 700 Sorry, minus 7,500 Newton is the answer. Okay, is it clear? I will read the question. Velocity time graph of an object of mass 20 gram moving along the surface of a long table is given below. Okay, look at here. Here you can see the picture that is given in your textbook. Okay, that is figure 3.13. Okay. So, once again I will read the question. Velocity time graph of an object of mass 20 gram. You want to convert this gram into kilogram by dividing by 1000. Okay. So, here m is equal to 1000 gram. Okay, we want to convert this 20 by 1000 kilogram. Okay. Then look at the graph. Here the initial velocity, that is 20 meter per second. You can easily find out from the graph. Then here the final velocity is how much the graph comes to rest. Okay, that is 0. Then here velocity becomes 0. So we can write u is equal to 20 meter per second and v is equal to 0 meter per second. Okay, is it clear? Then here time is also given. That is 10 seconds. Look at the graph, you can easily find out the time. Okay, here time is given, that is 10 seconds. Okay, is it clear? Then we want to convert this. Okay, so we have an equation for finding this. The equation is F is equal to ma. F is equal to ma. Okay, so we can write this equation as m into v minus u by t. Is it clear? Here a is equal to v minus u by t. So I write here as v minus u by t. Okay, so we want to substitute here the values. So here mass is 20 by 1000 kilogram. So we can write like this, 20 by 1000. Then here v is 0 and u is 20 by t. Here t is 10 seconds. Okay, is it clear? So while substituting this, we will get as minus 0.04 Newton. Okay, minus 0.04 Newton. Is it clear? So here the negative sign shows the frictional force is acting opposite to the direction of the motion of the object. Okay. So this is all about today's class. I think all of you got it. Thank you.